All right, welcome back again. In this tutorial, I'm going to continue with dimensions. I'm going to continue with what? Dimensions. All right, we're going to talk about dimensions. As we talked about in our previous video, that to find the dimension of a physical quantity, we use three things. We have that of the mass, which is given as capital M as a dimension, that of the length, which is capital L. Then we have the time as what capital T. So in this case, the dimension of it you talked about, this square bracket is used to represent what? The dimension of what? A physical quantity. A physical quantity. A physical quantity. All right. So meaning that if I write this mass in a square bracket, it means that dimension dimension of mass. Same way, if I write this volume in a square bracket, this is the same as the dimension of volume. Yes. So the same way, if I write this means that the dimension of what? Time. Great. All right. So basically, these are the things that we should note when we are talking about the physical or the dimensions of what physical quantities. So we base on these three fundamental what quantities to derive the dimensions of this other what quantities. All right. So let's say we want to find the dimension of what um, velocity, velocity, which is given by what the rate of change of what displacement, which is displacement divided by what time. So it means that if I write this velocity in square bracket, this is the same as this is talking about the dimension of what velocity. So this is going to be the dimension of displacement divided by the dimension of what time. All right. So in this case, we have now what is this displacement that we are talking about? This is basically um, distance traveled in a specified direction. So this here displacement here makes it a vector quantity, because it deals with what direction and what distance. But when I talk about just distance, I'm talking about a scalar quantity, right? So displacement, distance traveled in what a specified direction. Now, all is talking about distance. So we're still talking about distance. So in this case, length. We are dealing with what? Length. So we are using the three quantities. Length. So it means that we have length divided by what? Time. And this is the same as LT negative 1. All right. So this is the first one. Now let's continue to the next one. We have, let's say we want to find the dimension of acceleration. Acceleration. Now, acceleration is given by the rate of change of velocity. So velocity divided by what? Time. So it means that if I want the dimension of acceleration is equal to the dimension of velocity divided by the dimension of what? Time. Now, what is the dimension of velocity? As we did in the first one, which is given by LT negative 1. So LT negative 1 divided by time, the dimension of time, which is what? Capital T. And this is the same as LT negative 1, LT negative 1. So indices multiply with the same base, we add the powers, right? So this is going to give us LT negative 2. All right, let's move on to the next one. Force. So how do you find the dimension of what? Force. Now we know that force is given by what? Mass times acceleration. Now, so it means that the dimension of force will be equal to the dimension of what? Mass times the dimension of what? Acceleration. All right. So we are going to have the dimension of mass is given by what? Dimension of mass, which is what? Capital what? M. So we have capital M times the dimension of acceleration, which is this. So we have LT negative 2. And this is going to give us what? MLT negative 2. And this is the dimension of what? Force. Now, let's talk about the next one. Let's say we want to talk about the dimension of momentum. Momentum. And we know that momentum is given by what? Mass times velocity. Mass times what? Velocity. Mass times velocity. Now let's see. This is capital what? This is momentum. So the dimension of momentum is equal to the dimension of mass times the dimension of what? Velocity. And this is going to give us what? What happens here? The dimension of mass is what? Capital M. Then times the dimension of velocity, which happens to be uh, this. So let's cross check from here. This is LT negative 1. So times LT negative 1. All right. So meaning that the dimension of momentum is what? MLT negative 1. All right. So that is that for what? The momentum. Now, so let's move on to the next one. Let's look for that of impulse. We know that impulse is given by what? Um, Force times what? Time, right? Force times um, time. Force times time. Force times what? Time. All right. So let's see. This is force times time. So it means that the dimension of impulse will be equal to the dimension of force times that of the dimension of what? Time. What is the dimension of force? Now, we have this here, the dimension of force. So we have M L T negative 2 times T. Now you can see that we have T and T. This is exponent 1. So multiply with the same base, we add, right? So this is going to give us M L T as for negative 2 plus 1. And this is going to give us what? M L T negative 1. And that happens to be the dimension of what? Impulse. Now let's try another one too. Let's try another one. Work. Work. We know that work is given by what? Force. So force times what? Distance. So work is said to be done when force move something in the direction of what? The force. All right. It moves an object in the direction of the force. So we are going to multiply the force by what? The distance. All right. So what happens here? So it means that the dimension of work will be equal to dimension of force times the dimension of what? Distance. And we know the dimension of force to be what? M L T negative 2 times distance. So this is distance. So we represent with L. Now what happens? We have M L. This is exponent 1. This is also exponent 1. We have L exponent 2 T this. So this happens to be the dimension of what? Work. The dimension of what? Work. The dimension of work. All right, let's try that of the dimension of what? Energy. Dimension of energy. Now, it's either we go for, we can talk about the uh, kinetic energy or the potential energy. All right, and we know that kinetic energy is given by half of uh, kinetic energy is given by half mv squared, and this the potential energy. Potential energy is given by mhgh, mgh, mgh. All right. So mass times acceleration times what? The the height, right? All right. So let's see. Let's go with the potential energy. I think that will be better for us. If you go for this one too, you are going to get the same because the dimension of a constant is nothing there. So we're still having the same result when we try to use this or either this or this. So going with the potential energy, we have the dimension of energy being equal to the dimension of mass times the dimension of acceleration due to gravity times the dimension of what? The height. All right. So mass, capital M, acceleration is the same as L, T negative 2. Then we have height, which is the same as the length. Talking about distance. So what will we get here? What will we get here? Now we have M, L. This is L, L. So exponent 2, negative 2. So this is the dimension of what? Energy. All right. So these are some examples on the dimension of some physical quantities. So try to practice, or you can try on that of the dimension of, so try that of the dimension of pressure, You can try on that of dimension of what? Density. You can also try on that of the dimension of what? Power. All right. So that is that for today. Thank you for watching.